So here is the example. It says the figure below shows a sketch of the curves with equations y equals x cubed plus 3 and y equals minus x cubed plus 2x plus 3. We can see the sketch, and then it says the finite regions bounded by the two curves are shaded. Find the exact total area of the shaded regions. So the first thing we want to do here is actually find the points of intersection of the two curves. So we can see them on the sketch, but we need to find them because those will provide our limits for the integration. So to find the points of intersection, usually we solve the equations simultaneously. So for two equations like this, I'd probably just equate the y's together. So x cubed plus 3 equals minus x cubed plus 2x plus 3. If we rearrange this, we get 2x cubed minus 2x equals 0. We can then factorize and we get this. Factorize again, got a difference of 2 squares there. And so we end up with 3 answers for x. X is 0, x is negative 1, or x is 1. Those correspond to the points here on the sketch. So this one must be negative 1, this one must be 0, and this one must be 1. Now, for the purposes of this question, we only care about the x coordinates of the points of intersection. That's because it's only the x coordinates that give us the limits for the integration. Now we can actually move on and do the integration. When you have two curves like this, there are different ways of tackling it, but my preferred way is to think about doing the integration like this. So take the top curve, whatever curve is on top, and then subtract the bottom curve. If you write the expressions in this way, you can integrate all together, all at once. So this is the key idea for this topic. Now, as you can see here, I've split the region into two separate areas, area A and area B. And that's because in each of those areas, the top and the bottom curve are actually different. If we start with area A, hopefully you can see the red curve is on top. So when we integrate, we're going to do the top curve, which is the red curve, so x cubed plus 3, minus the bottom curve, which is in this case the blue curve, so minus x cubed plus 2x plus 3 all inside brackets there, and then integrate with respect to x. The limits for region A will be negative 1 and 0, and from here it's just a case of tidying up, integrating and putting in the limits. So let's do that, and it comes out as a half. So that's area A done. Now let's do something similar for area B. In area B, now the blue curve is the top curve. So we'll do minus x cubed plus 2x plus 3 as the top curve, and then minus the bottom curve, which is now the red one. The limits, in this case, it will be 0 and 1, and then go ahead and do the integration. Subbing in your limits carefully, and you will get a half. So that means if we want the total area of both regions A and B, that's just going to be a half plus a half, which is 1. So 1 unit squared. And that's it. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.